Welcome back. We now want to take a look at what materialized within your target schema after our previous successful run. Remember, we only configured an ID graph, and we will query that output here in a moment. But first, let's address what these other materializations are. When you first run a profiles job within your target schema, profiles will generate a number of registry tables. Though you can query these tables, they are not meant for modeling or activating. These registry tables contain metadata that helps profiles keep track of your runs, dependencies, and other functions. It is worth noting, profiles will never drop these tables as they are always needed for runs. If they are accidentally manually dropped, the next profiles run will error, and we will have to manually create those again for profiles to resume operating within the same schema. Additionally, profiles will also create some underlying base tables. Many of the SQL scripts run ephemerally, but there will always be some underlying tables that are persisted after each run that ultimately get used for the final output views that are created at the end of a run. These final views are what are meant to be queried, modeled on top of, or used for sources for activation. Given that these base tables are time-bound to the latest run, means they are only as fresh as the latest profiles run, and stale as soon as you perform another profiles run. When you perform a new run, profiles will recreate these base tables and change the underlying view definitions to point to the latest base tables. A good rule of thumb is to set a retention policy within your profiles project to keep your schema lean. As mentioned above, profiles will not drop the registry tables, but it will clean up some of the underlying base tables that are considered stale and no longer needed for the final views. We will look at how to do that in a later video once we have a fully built project ready for production. Let's now take a look at our ID graph view that was generated after our last PB run. You will notice a total of 5 columns. There is a user main ID, which represents your resolved ID. We then have the other ID column. This column represents all of the different ID values associated to a single main ID. Next, there is an other ID type column. This represents what ID type the associated ID value is. Remember, these were defined within your entity definition in your PB project YAML file. We also have the valid at timestamp, which represents when a particular ID was added to a main ID. Finally, we have the first seen at column, which represents a timestamp that the other ID value was first seen across your different sources. In a later version of profiles, we will also add some additional metadata to the graph so that you can observe the source tables each specific ID value was extracted from. If you query your ID graph in order by the main ID, you will notice that the data structure of the graph is long, not wide, meaning the main ID is duplicated per other ID. So you can see for any user all their associated aliases that were discovered from your most recent run. Depending on your business context, your entity, your ID types, and your source data will determine what a healthy ID graph looks like for a single customer. For unknown users, you may only see one main ID associated with one anonymous ID. For known customers, you may see many anonymous IDs, an email, a user ID, all rolled up to a single main ID. Let's now address overstitched or merged users. The ID stitcher model is completely deterministic, meaning it will only stitch direct connections that exist in your source tables. A common scenario after running and building your initial ID graph is to have multiple distinct users who were merged into a single main ID. This is caused by other ID values that may be associated with 2 or more separate users that collide. This may be desired behavior if your entity is of a higher grain than a single user, like a company or business entity. However, for an entity that is meant to represent a single user, this is not desired behavior. So it is important to QA your ID graph first and solve for some of these issues if they exist, prior to building features. If you don't solve this first, some of your users' feature values will be over-aggregated and not be represented accurately. Let's do a quick analysis on our ID graph to see the health of this ID graph. We will now get a count of other IDs per main ID and sort the output by that count in descending order, so that we can get a look at the main IDs with the highest other ID count. It looks like we have some pretty high counts here. The number one offender has 68 other IDs. That doesn't seem right. Let's query the ID graph and filter for this example main ID to get a look at the graph for this specific user. There are a lot of anonymous IDs and device IDs here, more than to be expected. As I scroll down, you can see there are actually 2 emails and 2 Shopify IDs. Looking at the email values, it looks like these are 2 separate users. Somehow these users got merged together, which is not desirable. Any features built on top of this main ID would not be accurate. Let's check the next user. It looks like the same situation happened here. We will need to figure out what other ID within these graphs were linked to 2 separate users and potentially modify our stitching process to address this issue and see if we can decouple these users from each other. To figure out what other ID merged these users together, we need to query one of the underlying base tables that gets created to support the ID graph. This table is called the internal edges table. This table represents the raw nodes, or ID values, collected from the source tables and what other identifiers they are directly linked to within the sources prior to generating the final resolved main ID. We can run manual queries directly on the edges table in order to find out where this direct link is coming from. Additionally, we can also use the PB Auditor tool, a feature of Profiles, in order to run a more detailed analysis on your ID graph. In the next video, we will take a look at the PB Auditor and how to perform some analysis on your ID graph, as well as some additional manual queries we can run.